Welcome to the Introduction to an Electric Drives. When you come to this course, it is assumed that you already know about how electric motor works. That means how DC motor works and how induction motor works. Knowing how an electric motor works is not enough. It gives only an understanding of physical principle of torque producing mechanism, that is how torque produced from electric current. But selecting an electric motor for an application and predicting performance of the load is different thing. This is what the subject electric drives is about. After completing the course Fundamentals of Electrical Motors on DC motors, induction motor or BLDC, SRM, PMSM or any other motors, one must understand the fundamentals of electric drive, because this is a real skill where you can utilize your knowledge of how an electric motor works and bring it to an application level of engineering. So you might not get paid for knowing that how an electric motor works, but you may get paid for suggesting a suitable motor for an application and for suggesting performance improvement like efficiency, cost or the torque ripple minimization. Thus, learning fundamentals of an electric drive will be valuable and rewarding in your career as an engineer. So let's start. What is electric drive? Electric drive is about giving a purpose to an electric motor, that means application based. Electric drive is about understanding behavior of motor on load, how motor will perform on certain load. That means first we need to understand the load, and it is assumed that we already know about the motor, how it produces torque, that we know. Electric drive is about fulfilling functional requirement as well as to improve the performance of the system. That means fulfilling functional requirement of both motor and load, and how we can improve the performance in terms of efficiency and other parameters. So we can say electric drive is equal to motor plus load plus device used for speed control and or performance improvement. So ultimately the device used for speed control and performance improvements are the power electronics devices in modern day. But it may be also the other motors, AC motor, DC motors, like in the previous or old conventional variable speed drive of the DC motor speed control, we use DC generator and the AC motor to run that DC generator. So by controlling the field winding, we control the speed of the DC motor in that era. But now it means the power electronics devices to control the speed or to fulfill the other requirement of the motor and the load. So we can say electric drive is equal to motor plus load plus power electronics and control unit. If we represent in the block diagram form, it will look like this. So first we will have the power electronics and control block, which controls the power to the motor, and motor will produce the torque required for the load. That means we first need to learn the load and then motor and then power electronics. So now because we come to this course, we already understand the how motor works. So first we need to understand load, its characteristics, then we utilize our knowledge of motor and power electronics control to get the desired performance improvement and functionality for the application. So let's first start defining the load, motor and power electronics and control unit of the electric motor drive. So let's start with the load. Load is a mechanical device able to rotate around axis to fulfill certain purposes. That means load is nothing but the mechanical devices which is able to rotate. But load is not capable of producing a torque required for the rotation. That means it needs some torque producing device to be attached with it. However, most loads develop the torque opposite to the supplied torque while it starts rotating, like fan and blower and pump. But some loads are also capable of producing opposite torque at standstill, like lift. So loads need to rotate at desired speed and torque to fulfill its purpose. That means if load demands X amount of torque to rotate at speed Y. So we can understand like this: the load is the mechanical device. When we need to rotate the load at certain speed Y, we require the fixed or minimum torque, which is amount X. So this amount of torque is required to achieve this speed for particular load. This is how load, speed and torque characteristic can be defined. So in general, load demands higher torque to rotate at higher speed. That means if we want to rotate the load at higher speed, then obviously required torque will also be high, which is opposite in case of motor torque development. We will see that. So this is all about what load is. So now understand the motor in terms of torque speed as well, so that it will be helpful in further section to understand the torque speed characteristic and how to match the torque speed characteristic. So let's discuss what is motor. Motor is a mechanical device that converts electric energy into mechanical energy. Motor produces a fixed amount of torque at fixed speed. That means it produces a certain amount of torque at certain speed. So in general, a motor produces less torque at higher speed. So if we increase the speed by considering the constant power region at higher speed, motor developed torque is reduced. So motor is device which produce torque, right? But it is also depend upon the speed. At higher speed it develop the less torque, at lower speed it develop the higher torque, right? It is not straightforward but for all motor, but it is in general. So we will discuss about the different torque speed characteristics of the motor as well as of the load. But load means it required the torque and motor means it developed the torque. In terms of speed, we need to rotate the load at certain speed. For that we require the minimum amount of torque, and here in case of motor we need to generate the torque at particular speed. So we will see how to match this characteristic and what's happen when motor is attached to the load. That we will discuss in further lesson. Now discuss about the what is power electronics. So functional requirement and performance improvement of the system. This is the main aim of the power electronics and control unit of the electric drive. So what are the functional requirement? It may be conversion of AC to DC or DC to AC depending upon the motor requirement and availability of the supply, and it includes the performance improvement like the efficiency and other parameters. So it includes functional requirement of both load and motor. So some functions are required for the motor, that is power supply nature and shape, and for the load, that is speed and torque requirement. It is required for both fixed speed as well as variable speed application. As we have seen, in some variable speed application can also be fulfilled without the power electronics with the old age method, that is by using the another motor and generator set, but which is not feasible due to bulky and inefficient way. So nowadays we require the power electronics for all drive, but it is not like that. It is also required for the fixed speed drive because of the type of motor, right? That means, for example, fixed speed drive requires power electronics to convert AC into DC, while motor is DC and available supply is AC. Similarly, When AC motors need to be used on portable devices, power electronics is required to convert DC into AC. However, power electronics and control block is mainly required for speed control and performance improvement like efficiency improvement and torque ripple minimization. The question of how to accomplish this is not being addressed at this time. We will talk about it later depending upon the type of motor and drive. For the time being, let's start with the most important step, understanding the speed torque characteristic of the load and the motor in next section.